outside of Fleming. Honored to have you with us today. Of course, the great honor to this institute and to the research area in Greece, I think, made today by the two distinguished guests that we have. Two esteemed scientists in the field of immunology, but extending in many other disciplines as well. Professor Bruce Beutler, who we like to thank sincerely for the time and effort spent to stay with us during the last few days with a heavy program, I must admit. So thank you sincerely even more. And Argyrios Theofilopoulos. I'm sure you know Argyrios a lot because he has visited us quite a few times. He's an eminent immunologist working at Scripps. He's been chairing the Department of Immunology at Scripps. And in fact, we will have in this session first Ari Theofilopoulos warm us up a little bit in the field of immunology with his lecture. And then we will have an open discussion with both Professor Beutler and Professor Theofilopoulos to ask questions more generally about directions that research and innovation, translational research and innovation, as we said in our talk, will be. So I'd like to call first Argyrios Theofilopoulos. Argyrios finished the medical school in Greece and followed specialty in pathology, but then he turned pathology into rheumatology and immunology and started very heavily working on research projects rather than clinical settings. That was his liking. He's a distinguished professor of immunology at the Scripps Research Institute, and the floor is yours.
Okay.
And the people is yours. Yours.
Good afternoon, and thank you for coming. Of course, it's a great pleasure for me to be back here. It's a great institute for which you are all should be. All of you should be very proud. And of course, we have a great leader, George Colliers, whom I think, I believe, has added considerably to the status of this institution. And I thank George very much for inviting me to come here and for his generosity throughout this trip. Now, what I would present will be relatively brief, and I have from the outset to indicate that whatever I will present would not be possible without the foresight and the generosity of my dear friend and colleague, Professor Beutler, who developed hundreds of EMU phenovariants, and he was generous enough and to collaborate with me and providing these mice that allow us to obtain definitive answers with regard to the role of nucleic acid sensing toll-like receptors in the pathogenesis of autoimmunity, and very likely of many other processes and diseases. So the interest in my laboratory in general is in the identification of predisposing and effector genes in systemic autoimmunity, more specifically in lupus, the prototypic such disease. And we define as predisposing genes mutated or allelic variants that they lead to the gain or loss of function, and attempt to identify them primarily by forward genetic approaches based on dense chromosomal maps based on the presence of certain polymorphic markers such as microsatellites and or SNPs. Now, because this approach moves from the phenotype to the genotype, is unencumbered by any preconceived notions, and therefore offers the opportunity to identify novel genetic contributions in these diseases. In contrast, we define predisposing genes, normal genes, in that the autoimmune responses, like a normal response, they use the same mediators, the same molecules throughout the initiation, propagation, and completion of these processes. And usually we attempt to identify this type of effector genes by reverse genetics, particularly gene deletions, but some of them can also be identified by the following approach. Now, as I have indicated, the center of our research is on the pathogenesis of lupus, a disease that afflicts primarily women of childbearing age, and a disease that is characterized by a multitude of abnormalities in T and B cells, and in particular the presence of several types of autoantibodies, among which those directed against nucleosomal and spliceosomal antigens typically predominate. Now, the American Rheumatism Association has devised 11 laboratory and clinical criteria listed here, and it is stipulated that the presence of any four appearing simultaneously or sequentially is sufficient for diagnosis. Therefore, if one takes this stipulation and applies some simple mathematics, it becomes very evident that this disease is highly heterogeneous. Not only heterogeneity is the characteristic of this disease, but it also is a polygenic disorder, and it is affected not only by genetic elements or contributions, but also several environmental factors, some of them stochastically imposed, some of them may be even iatrogenically induced. Therefore, because of this, defining the genetic basis of this disease in humans is extremely difficult. And for this reason, we and others have attempted to provide initial characterization of genetic contributions using predisposed mice, that is, strains that they develop in a predicted manner, a disease that pretty much resembles the human disorder. The mice that we use for several years, they include the classical New Zealand mice, of which the NZP develops hemolytic anemia. The MGW is relatively free of disease, and the hybrid develop a disease that pretty much resembles the human disorder. Another type of mouse that we use is the BXSD. This is derived from a single cross between SBD and B6 mice. And in these mice, unlike the human situation, the males develop much more severe disease. And this is attributed to a large translocation from the X to the Y chromosome near the pseudoautosomal region, leading to the duplication of approximately 17 genes, of which the most important is duplication of TLR7. And finally, another mouse is the MRL, which has a complex genome, and in this mouse, due to an early retroviral transposon insertion, the major apoptosis mediating gene, the FAS, is defective. These mice develop massive lymphadenopathy and splenomegaly, and an early severe lupus-like disease. Now, for many years, we and others attempted to characterize this disease on the basis of the adaptive immune system. And we found a variety of abnormalities with regard to the composition of the T and the B cell repertoires, some problems in the induction of tolerance, etc. However, despite these efforts and the countless papers published in this area, we were unable to answer as to what is the initial trigger of this disease and why the disease is characterized by such a broad spectrum of autoantibodies, particularly particularly against those directed towards nuclear antigens. Now, these questions then began to receive some answers with the advances that Bruce and others provided on the characterization and composition of the innate immune system. And it was very clear from characterizing this innate system that the major characteristic was the induction of responses that were predominated by the hyperproduction of type 1 interferons. Therefore, because of this and other evidences in the literature, which we don't need to review at this point, we first created lupus mice that were deleted of the common receptor for all type 1 interferons. As you know, there are several type 1 interferons, all binding on one receptor, including the alpha, the multiple types of alpha, the beta interferon, as well as others such as the tau, the delta, the epsilon, etc., and the omega. But among them, the most important from the immunologic perspective are the type 1 interferons, alphas, and a single beta. And so initially, we created NZB mice lacking the common receptor for the type 1 interferons. And as seen here, both the homozygous deleted mice exhibited extended survival, and this was seen even in the heterozygous deleted mice. Compare this in relationship to the wild type of mice. And all humoral, cellular, and histologic disease characteristics were profoundly reduced. Based then on this finding, we questioned, is it mediated, the disease-promoting effect, through the multiple alphas or the single beta? And in order to address this, we created then NZB mice lacking the interferon beta. And as it can be seen without going into details, disease was not affected at all by deleting the beta. Therefore, the disease-promoting effect was mediated by the multiple alphas. And subsequently then, in order to provide some evidence that this finding may have application in clinical medicine, we obtained an antibody from Goldschreiber that was made in mice. So this was a mouse antibody directed against the mouse common receptor for type 1 interferons. Usually people, when they treat mice with antibodies to receptors or any molecule, these monoclonal antibodies have been made in rats. And because they are made in rats, when you treat the mouse for extended period of time, the host develops an antibody against the heterologous immunoglobulin, and therefore you cannot do it for extended period of time. Here we use a murine antibody directed against the mouse common receptor for type 1 interferons. And as it can be seen here, again, without going into great details, all the characteristics of the disease, including IgG2A, anti-chromatin antibodies, anti-nuclear antibodies, kidney deposits, glomerulonephritis score, and survival were extended. It was noted when we were doing this work that if the treatment was begun early on in life, the results were very clear-cut, that is disease reduction. However, this effect was reduced as the treatment was applied later and later, indicating that once the adaptive system comes into play, then interfering with the innate is not sufficient. And one either will use only those treatments that inhibit the adaptive system, or combination thereof, that is interfering with both the innate and the adaptive system. With this finding then, it was evident that perhaps this induction of type 1 interferon might have been mediated by sensors of nucleic acids. And as you know, there are several sensors by which we can sense not only foreign nucleic acids from pathogens and viruses and bacteria, but also even under sterile conditions, our own nucleic acids. And there are several classes of such sensors. One class is the endosomal TLRs, TLR 3, 7, 8, and 9, of which the TLR 3 recognizes double-stranded RNA, the 7 and 8 single-stranded RNA, and the TLR 9 hypomethylated DNA. So these types of sensors, when nucleic acids derived from pathogens and or self enter into the endolysosomes, a signaling is provided, which through a variety of transcriptional factors leads to the production of type 1 interferons. Another class of sensors that they are confined within the cytosol are the helicases, RIG-I and MDA5 that recognize various types of RNA. And finally, a multitude of sensors, some of them depicted here, including the RNA polymerase 3, EP16, and in particular, the C-gas cyclase, all of them that recognize DNA, and finally, AIM2 that appears instead of inducing type 1 interference via the skin, they lead to the assembly of an inflammasome and production of IL-1 beta and IL-18. Now, while there are such a multiplicity of DNA sensors in the cytosol, it is not clear whether there is any redundancy among them, and or some of the sensors are functioning in a particular cell-specific manner. That needs to be addressed. At any rate, as I have indicated, there are several types of sensors acting either within the endolysosome and or the cytosol, by which we sense nucleic acid derived either from foreign intruders and or, in certain instances, by own nucleic acids under sterile conditions. Now, various authors then try to address the issue whether the endolysosomal specific TLRs are involved in the pathogenesis of systemic autoimmunity. And they tended to create knockout mice predisposed to the disease, either for the TLR7 or the TLR9, and rather conflicting results were presented. With the TLR9, they suggested that there was a reduction in anti-DNA, but overall disease was enhanced. Whereas with the TLR7 deletion, there was a reduction of autoantibodies against RNA, but the disease was not fully reduced. So there was question how now these specific TLRs affect the disease. We suggested that perhaps the results were erroneous, suggesting that the TLR9 is beneficial and the TLR7 detrimental. We thought that this was erroneous because both of these TLRs are co-trafficked by a molecule that is called ANC93B1. And because this molecule exhibits higher affinity for TLR9, when the TLR9 is deleted, then there is higher availability of the ANC93B1 to interact with the TLR7, traffic then the TLR7 into the endolysosomes, and that then can provide a more damaging autoimmune response. To better address this matter, we were lucky that Bruce at that time had developed through the EMU mutagenesis a mouse that he called it 3D, three-dimensional. And he called it so because mutation of this particular molecule led to the absence of signaling by TLR3, 7, and 9. And therefore, we used congenic mice that they had the 3D mutation of ANC93B1 and follow then the effect on the disease process. ANC93B1 was shown by Bruce, Hideplo, and their associates that is physically bound in the endoplasmic reticulum to TLR 3, 7, 8, and 9. And when nucleic acids enter into the endolysosomes, then the ANT93B together with the TLRs traffics from the endoplasmic reticulum into the endosome where recognition takes place. And the recognition by TLR of nucleic acids takes place in the endosomes because within this acidic environment, proteolytic cleavage of TLRs takes place, and this proteolytic cleavage is by certain proteases. This cleavage is thought to be a prerequisite for not interaction with ligands, but for signaling. And why this is so, it's not fully known, but it may be that upon proteolytic cleavage, there is better dimerization of the TLRs and better attraction of adapters and signalings downstream. So to make the long story short, we made congenic lupus predisposed mice that carry the ANT93 mutation or 3D mutation and follow the disease development or modification. And as it can be seen here, when we did that with the DXSB mice, which carried, the males carried the duplication of the TLR7, again, without going into very details, autoantibodies were reduced, survival was extended, and renal disease was reduced. We performed a similar experiment with the MRL facial PR mice, that is the mice that have a mutation in the major apoptosis mediating molecule, the FAS, and once again, all the disease characteristics were profoundly reduced. Moreover, and interestingly, not only the anti-nuclear antibodies were reduced, but all the diversity, or most of the diverse autoantibodies that they are seen in lupus were affected, including autoantibodies against cardiolipin that is associated with antiphospholipid syndrome in humans, autoantibodies against beta-2 glycoprotein, and myeloperoxidase, autoantibodies also that are associated with certain forms of vasculitides. And also, even when we created congenics, NCB mice carrying the ANT93B mutation, even the anti-erythrocyte response was totally absent. Now, how the anti-erythrocyte response was affected was rather a puzzle, because the red cells, as you know, they do not carry nucleic acids. They expel rather the nuclei in the mitochondria, so they don't have DNA. Nevertheless, they can have some species of RNA. Moreover, the recognition might occur prior to the expulsion of the nucleic acid, and or the recognition might take place by the uptake of nuclear material that happen to still display on its membranes, on its outer periphery, membranes, cellular membranes that carry still the IPNI molecules. So this perhaps may provide an explanation why by limiting signaling from the endolysosomal TLRs, one affects the diversity of antibodies. That is, it seems that the nucleic acids carry cargoes of other self-molecules, and by acting as adjuvants, they promote a diversity of autoimmune responses that one sees in patients with systemic lupus erythematosus. We then to determine what is the contribution of T cells versus B cells. We created mixed chimeras using B cells that have different allotypes from wild type and 3D mutant mice, and simply we found that all the autoantibodies were derived from the wild type B cells, thereby indicating that expression of TLRs recognizing nucleic acids within the B cells, intrinsically into the B cells, is a prerequisite for the development of this disease. Thereafter, we pose questions pertaining to the role of plasmacytoid dendritic cells. Plasmacytoid dendritic cells are thought to be the major type 1 interferon producers. It is generally found that plasmacytoid dendritic cells produce at least 1,000-fold more type 1 interferon than any other type of cell in the body. Every cell can make type 1 interferons, but the plasmacytoids are much more prone to respond and produce high titers of type 1 interferons. And to address this matter, first we created mice, New Zealand mice, deleted of a common transcriptional factor which is called IRF-A. This factor is expressed primarily in the hematopoietic system, and deletion of this factor leads to the absence of plasmacytoid dendritic cells as well as of certain types of disease like the CD8 plus disease. By doing that, again, I'm not going to go into great details, disease was greatly reduced. However, with this experiment with the IRF-A deleted mice, we could not conclusively indicate that the plasmacytoid dendritic cells are absolutely necessary. But once again, as apomechanistes, Bruce had developed another mutant. And this mutant was called SLAC15A3 or feeble mutant. In essence, Bruce and his collaborators identified three mutants that have mutations in three types of molecules. One is called AP3, and this molecule acts as a conveyor of molecules from the endoplasmic reticulum into the late endosomes, AP3. Another class of molecules are called block 1 and block 2. These are the biogenesis of lysosome organelle complex molecules. And again, when they were mutated, either the block 1 or the block 2, the AP3 is a heterotetrameric, whereas the blocks are heterooctameric. So deletion or mutation of any of subcomponents within these molecules led to defective generation of plasmacytoid dendritic cells and production of type 1 interferon. Specifically for the AP3, any subcomponent of this heterotetrameric could do it. With the blocks, the deletions or mutations were for the block 1 in a molecular component that's called disbinding, whereas for the block 2, the mutation was in a subcomponent that's called HPS5, as I recall. So mutations in these molecules led to the inefficient generation of plasmacytoid dendritic cells and the responses to nucleic acids as indicated by the production of type 1 interferons. However, in humans, mutations of either of the AP3 or the block 1, block 2 is associated with a peculiar syndrome that is called Hermansky-Pudlak syndrome. In these patients, there are broad abnormalities in the so-called lysosome-related organelles. There are different types of these organelles. They can be melanosomes, there can be dense bodies in platelets, there can be lipid granules in T cells, and therefore these patients with this rare syndrome develop several degrees of oculocutaneous albinism, hemorrhagic diathesis, with abnormalities in T cells, etc. But in contrast to these two types, that they have these profound defects, broad defects, mutation of the SLAC15A4 was not associated with such diverse abnormalities, apart of the inability of the well-developing plasmacytoid dendritic cells to respond to nucleic acids and produce type 1 interferons. SLAC15A4 is a member of a family of solid carriers of peptides. There are approximately 300 genes that encode such transporters, and they are within several families. One of these families is the SLAC15 family. and has 4 members, the A1, A2, 3, and 4. Of them, the A1 and 2 families indiscriminately almost transport large numbers of dipeptides, and in particular tripeptides. More than 8,000 different tripeptides can be transported, and at least 300 to 500 dipeptides. In contrast to A1 and A2 that lack discriminatory capacity and transport from the endolysosomes into the cytosol a variety of dipeptides and tripeptides, the SLAC15, A3, and 4, they have specific ability to transport histidine and histidine-related peptides. So that's the particular molecule that we elect them to work. And when we make congenic mice having the mutation of this 12 transmembrane span molecule, that they're called feeble mice, once again, the mice had reduced responsiveness to CpG, yet the numbers of plasmacytoid dendritic cells were not affected, the production of interferon severely compromised, anti-chromatin antibodies, anti-nuclears, splenomegaly were reduced, and survival was extended, thereby providing strong evidence that plasmacytoid dendritic cells, and in particular the production of type 1 interferon, is a central component in the pathogenesis of this disease. The exact mechanism by which SLAC15A4 mutation compromises recognition of nucleic acids by endolysosomal TLRs remains to be determined. Several possibilities have been considered, such as an effect in the generation of specific lysosome-related organelles characteristic for the plasmacytoid dendritic cells. Other possibilities is this mutation compromises acidification of the endolysosome, and so forth and so on. We have been doing experiments in this direction. We don't have yet a clear evidence how the SLAC15A4 does it, but we have also simultaneously developed a high throughput assay so as to find pharmacological inhibitors, and I think we will be very successful in this area. So thank you very much.
Thank you so very much. It was great. Very insightful, very complete picture of lupus pathogenesis, just as we expected it from you. And thank you very much for doing this. This seminar is open for questions, so if you'd like to discuss any questions, I have one just to warm up the room. No, not yet. Not yet.
Okay, go ahead.
This will be questions for your seminar.
Okay.
Okay, so one of them is you showed us very insightfully the mechanisms that are implicating the production of autoantibodies.
Mm-hmm.
And then you were referring to disease.
Mm-hmm.
Are autoantibodies always related to disease, even in this mouse? And what happens in humans? In humans, we hear many times that the problem with lupus may not lie with the autoantibodies.
I think if anybody has proposed something like that, that the problem, the disease does not lie in the autoantibodies, perhaps is too strong statement and incorrect. There is the anti-nuclear autoantibodies and the anti-red blood cells autoantibodies and the anti-cardiolipin autoantibodies, etc. Obviously they contribute to disease, no doubt about it. That does not exclude the possibility that some components of the disease may have a cell-mediated component, but interfering with the production of autoantibodies by a variety of means, as shown here, have profound effect in the disease progression. So it's well taken your question, but I will not. I will not think that I will minimize the importance of autoantibodies in this classically humorally mediated autoimmune disease.
Thanks very much. It's a complete answer, I think. But I will not discuss more on that. I was also referring to the nephritis part.
Nephritis.
And whether the nephritis is linked with the antibodies, or it could be cytokines which act directly on the...
Well, that does not exclude, when we say the antibodies, we do not say that they themselves mediate everything. Of course, there are secondary epiphenomena. Once the antibodies are finding their target and the immune complexes are formed, they're going to trigger cytokines and chemokines and attraction of helper T cells in the kidney, etc.
Thanks very much. Another question from the room.
Hi, great talk. I can ask something. In this mice, have you checked autophagy? Maybe autophagy is linked to
Autophagy. Autophagy has not been checked specifically here, but evidences exist, and some publications have presented some findings that can be taken to indicate effective autophagy in lupus.
If not,
I have a question.
He has a question.
Yes, if you were to try to find mutations that mitigate lupus, how would you do it? I mean, in principle, we might have set up a screen for survival of mice, and we could have found the UNC93B1 mutation that way by finding mice that survived, or the SLAC15A4. But what do you think would be the most sensitive assay to use? Survival or positive ANA or what?
Well, when you do such testings or EMU mutagenesis, I suppose you want something that you can assess effectiveness relatively fast. So if you are waiting for the survival, that may be too late, and a lot of mice will be accumulated, and it will cost you a lot of money. But if you look, let's say, for anti-nuclear antibodies, and you see considerable decrease, that may be useful. Autoantibodies, in general, appear relatively early in the disease process, and so that might be useful. Now, it doesn't mean that because one does mutation of the SLAC15A4 and any one of these molecules and see effect on the disease, that similar mutations will be found in humans with a corresponding disease. For example, very few, if any, humans have mutations in FAS when it was looked. In humans, maybe multiple genetic elements contributing very small components in the disease process, and acting in concert may cause this disease. So it's not as profound genetic modifications as those seen in the mice that they are applicable in the human situation. In fact, more than 60, perhaps to 100 genes has been claimed to contribute to this disease, acting in concert. And some of them may be transcriptional factors, maybe super enhancer, perhaps acting far and away from the putative loci by looping out of the DNA. So there are complex issues to identify the genetic elements in the human disorder.
any more questions? One more, last one from George.
Just to get into a translational mood, what is your approach to the development of the inhibitor of the SLC?
That's what I said.
Like the particular aspect of the
Well, because it's very
how do you
difficult.
go about inhibiting the molecular
Yeah. Specifically, the SLAC15A4, as I said, transports histidine-related peptides. And this is because histidine appears to have a strong buffering effect on the endolysosome. So, be that as it may, it's very difficult to develop a high throughput assay that addresses the transports of histidine peptides, because that will require, first of all, the SLAC15 to be expressed on cell surfaces, as for example in oocytes, and secondly, one would have to use radiolabel, perhaps 38 thymidine components to see how one might interfere. And this cannot be easily applicable to high throughput assays. So usually, we go through an assay that tries to identify type 1 interferon decreased production upon incubation with TLR ligands. Once we identify such inhibitors, then we have a more restricted number of compounds to be assessed for specific effectiveness in histamine transport.